Hello, folks. Let's talk a little bit about what Suricata is and a little bit beyond then about some of the new things and funny experiences we had. My name is Peter Manev. I met this colleague and a friend of mine now, this gentleman, this monsieur, Eric Leblond, here on a project called Suricata 16 years ago. Currently I'm a Suricata evangelist, that's the official title, and a co-founder of Samos Networks. But that's where we met with Eric, we love the project and the community, and we're donating a lot of time and contributions, everything, to the project. And can't believe it's been a bit of that time, but...
Yeah, so I'm Eric Leblond. I'm one of the co-founders of Samos Networks. That's my daily job, but I donate a lot of time to Suricata on the OESF, on some code too. We're going to see that later. And we were talking about psychological well-being in one of the previous conversations. So yes, it's about being with friends, building stuff to different people. So that was in Amsterdam with Victor Julien, who is the founder of the Suricata project. And it was around 10 years ago.
We still look the same though. Victor, I think, put the first line of code around 2007, but back then it was very different from what it looks on the screen now. Suricata actually has evolved to be something much bigger than initially thought, and it can, alongside alerts, it can actually do protocol transaction, flow logging, full pickup logging, even conditional extracted files, all those things. And it's been constantly evolving with time and with effort, thanks to a huge community and dedicated effort from the team. So as I said, first lines of code, 2007, initial release, 2008. It has evolved a lot since then. 600,000 lines of code now. Suricata is written in C, but there is a Rust conversion and implementation and adoption. Eric will chat a little bit about that later on. Suricata has the privilege to actually digest any sort of network traffic, regardless what type it is or what kind it is and what the intention is. It produces lots of different outputs, JSON structured format, protocol transaction, as we mentioned, alerts, which are a very small part of the whole volume of logs that Suricata produces, the PCAPs, and it has to do that at high speed. It has to do that while it's open source, community driven. It's adopted quite heavily out there. It's actually software. The Suricata is owned by a non-profit, non-government foundation called Open Information Security Foundation. The reason for that is so that Suricata is open source, GPL version 2 license, out on GitHub, but as often it's used by a lot by vendors too, and sometimes as a vendor you have to mix code, and when you mix code you have to be license aware, license compliant, and similar things. So for those types of setups, there is also a proprietary license, but Suricata is GPL version 2. So the idea there is to make sure it's free, open, community driven, and all that. So any more questions are answered on the link there if anybody ever has any doubts. So some of the challenges that we have to constantly deal with prior, post the release too, there is a huge variety of users and huge variety of use cases. A lot of our use cases and users are not known to us, and that's one of the challenges, but we know we have big, heavy organizations using us, like Google, Facebook, AWS, and similar. We're used a lot by enthusiasts, university researchers. Sandboxing, actually, a lot of the big sandboxes out there that are public, like Niran, Joe's, and Triage, they actually incorporate Suricata as well. Different NDR vendors, integrated appliances. There's a bunch of actually products that are using Suricata, and with that we have to actually keep the community happy and engaged because that's a very important feedback line for us, consortium members as well, and not all consortium members actually need or require a commercial license. Well, there's the technical part of the challenges. This is a non-exhaustive list, as the list is actually pretty long. But we have to operate at speeds from latest report is 400 gigabit a second to Raspberry type of installations and speeds and all that stuff. So imagine if you are getting, between 10 and 50 million packets per second, you have to match and do detection logic there over, let's say, 50 or 100,000 different detection vectors. So that's quite a heavy lift. With that, we take, for example, the input and the traffic capture, and that could be anything. I mean, there is little malware actors that care what the RFC says, and there is also regular vendors that also are non-RFC compliant, for example, when it comes to the traffic. So we have to deal with it regardless of the RFC. Because our purpose here is threat detection, right? So we need to ingest any type of threat intel, and with that, we have to actually do the output correctly. So export the data in a realistic scenario to data lake, get maximum context for the users, and similar. So there's technical, non-technical challenges and things to keep in consideration when we're actually doing the release cycle. So anytime there is a PR, you can follow the release and the development on GitHub, basically, because it's open source. So anytime there's a release cycle, usually there is a major version every 2 years, and the version is supported for 3. On average, there is a lot of security advisory and patching, and end-of-line policy. But on average, there's a patch every 2 months, give or take. And so we have to have a lot of all these considerations when we're actually doing a release, a major release, and the major release actually contains all the new features and goodies out there. So how did we get to 8? It's been 2 years of development. So having in mind it's 600,000 lines of codes, out of which, more than a third were changed. It's a heavy lifting, right? So there's a lot of C, there's a lot of Rust, there's documentation, there's a lot of features, there's a lot of new things that we'd like to just highlight. Probably the most important ones here that we can fit in 30 minutes, having in mind it took us 2 years to get here. So one of the additions or improvements is to improve the detection capabilities. So Suricata can understand, parse, log different protocols. So one of the challenges there is that we can log it, and we can log a lot, but it would be also nice to include that into detection. In other words, if you log it, you can use it in a rule, so to speak. So to be able to create an alert and to be able to create an escalation of that sort. So we actually, the team, added, you can see on the picture on the right, 107 new keywords. The keywords are basically buffers to where in the protocol or in the traffic you want Suricata to inspect, and can mix and match. If this and that and the other happens, then erase the event. Now, we have to have that in mind as well when we're adding new protocols. We have to add new keywords, of course. You can easily list them like so. I don't know if a lot of people know that, but it's a very good quick checker if you have a specific buffer or something that you can actually directly check in right away for Suricata to raise an alert. But the bottom line is that there was a 38% increase of those keywords compared to the previous Suricata 7 release. So that was a huge, huge uplift. There are some detection limitations, well, there were, because actually, initially when Suricata started as an open source project back in 2009, the signature language back then was even old. Never mind now, so it's actually older than probably some of the people in this room. So it suffers a lot from these limitations at an industry level, not just for Suricata, because one of the problems there was you can only match one direction of the stream, so to client or to server. That's how the inspection is done. However, instead of the rule writers were forced to write a couple of rules, so now they can actually do one and match on all any directionality, pardon me, in the same rule. So we had a lot of challenges with that, but that's solved for Suricata now, and it's actually one of the major things. So you don't have that limitation anymore. So this is where we introduce transactional rules. So instead of two rules, to server and to client, you can actually write one and mix both the response and, let's say, the request and similar, regardless of the protocol. So you can express both directions in the same, actually, logic. And, of course, have in mind that Suricata actually operates, the detection part operates not only on signatures, but also on Lua scripting and the output and similar. And sometimes, it's not always about being able to write the rule. You can actually have the data that Suricata produces and do a SIM query and escalate it from there, but it was inconvenient because that's one of the feedbacks that we got from the community and the people that are using Suricata.
So for your example that Peter is giving is quite simple. We are looking at an upload to a file server. That's the first part, file data to server, and then we check that we have in return a 500 status. So basically we upload the file, and the result from the server is the server has crashed. 500. So in one signature, now we can write this type of logic.
It's actually pretty nice to know when your application crashes out.
Yep.
But, improving the IOC matching. I think it was wrote you because you wrote the code. That part. So yeah.
Yeah. So in Suricata 5, one thing that have been kind of solved, we will see a little bit imperfectly on Suricata side, was the capacity to handle IOC correctly. The way you could handle IOC before Suricata 5 was to have one signature per IOC, so one signature per domain, one signature per IP, and even if it was working suboptimal is kind of a nice word to describe the situation. So in Suricata 5, so something like 4 years ago at least, the dataset concept was introduced, which is kind of simple. If you have a keyword that is, for example, matching on creating a string, you can match on a big list of items that you load from a file on disk. So quite simple. But one problem with that is that when you end up having a million IOC from MISP and you don't have you get one alert that says that something has matched, and you don't know what it is, you don't know why. So the way you need to do it is that you take the IOC, you look for the IOC in your threat intel solution, and then you combine everything if you know which field is the IOC. So that can be quite painful. So I've worked on fixing that by adding the support of JSON context in the dataset. So now you can load the dataset, which is not one entry per line, but new line new line separated JSON or JSON, and then put that directly in the context. So, for example, if we have this signature with a HTTP host, we are going to check everything in IOC and data.json, and we are going to be able to get the data and output the data in the alert. So, for example, here we are trying to match on this crazy name randomly generated, rw.top, and we get the context about it. So we can put in which key we want to put the context, and all the info from the IOC are getting into the alert event. So when you get the alert event in your SIM, in your data lake, in your SOAR, in your whatever, you know exactly why it did trigger, and you got all the context from your CTI tool. So that's quite convenient to analyze.
In all fairness, if a cat probably walked on the keyboard, it will probably be less entropy than this one, but yeah.
Yes, I think we will have more double letter from this one, I agree. So one other fight that has been done during the Suricata 8 making was to add more support for more protocol. Because if we are able to understand more protocol, we are going to have more coverage and more understanding of what is happening on the network. So, for instance, LDAP is super useful in most of our environments. So now we got LDAP support, so you can match, you can start to see people trying to look at your, trying to access data from the directory. And it's the same for the other protocol like SIP, ARP, at low level to be able to see what is happening on the ARP request, spoofing and stuff like that. And also some protocol that require decryption. Suricata is not with the decryption like DNS over HTTPS. If you have decryption in place, you can see the traffic for this protocol. One other big challenge, and I talked a little bit about that yesterday, is improving Suricata security. Security parse all the mud from the network. Anything goes, and we need to handle it. It's a bit like traffic light when they are red in Italy. RFC is just an information. And you have really bad driver, which in our side are the attacker, that just try to go out of the RFC. And why they want to get out of the RFC? Because if they are not analyzed, if they crash the system, they get unnoticed, so their attack is not seen, so they are undetected. So there is two paths of big security improvement in Suricata 8. One is to increase the usage of Rust. So Rust is a memory-safe programming language. So we are not subject to potential memory overflow, buffer overflow, sorry. I was going on memory. Yeah. So some buffer overflow or some usage like that, it's memory safe, so it prevents us from doing this type of error. So I think it decreased from something like 20% to 27% of the code now in Rust during the Suricata 8, with some huge improvement. And then the second one is Lua with sandboxing and rendering. So on the Rust side, I would like to thank the French or Canadian friends, because they did contribute libHTTP in Rust. So the original parser from 2008 was a C library parsing HTTP protocol, and they have converted they did convert the HTTP protocol in Rust. So thanks a lot for their contribution. And then we also have FTP, NIP and MIME parsing that has been translated to Rust. The second part of this securization project was to fix the Lua issue. So previously Lua was the Lua from the system without any sandbox. So as I mentioned yesterday, if ever you consider that the signature you cannot trust the signature that you are ingesting, people could potentially run arbitrary code if they take the control of the source of signature. So this was needing a fix in 2023. It has already been fixed by making Lua disabled by default, but a better way to do it, because Lua can be quite powerful, is to have Lua available by default, embedded into Suricata, but sandbox, so we cannot get outside. So no access to the local modules and stuff like that. Limitation in terms of CPU usage. All this stuff to limit the potential impact of a bad Lua script in the system. And as we were discussing with, the OESF team was discussing with the community and the consortium member, we discovered some new usage. One of them was a big usage of Suricata as an IPS, but the IPS being used as a firewall. So that was not meant to be like that. That's why the firewall mode has been introduced in Suricata to fix that. I'm going to give you some detail after that. And the second new use case is to be able to use Suricata in a library. So if one way or another you get access to packet, I'm thinking, for example, to Kunai, that could export the packet from the user, from the local host to Suricata to get the feature from Suricata, protocol parsing and stuff like that. This could be done as a library. So yes, Suricata as a library, you can register what you want from the Suricata stack. So application parsing, detection, just the logger, the output. So you can build your own mini Suricata as part of the system. You got some code example, and you can really customize everything you want via the output to get something that suits your need. And The firewall mode is just yet another mode in Suricata because we have a lot of modes. We got the IDS for passive analysis, IPS for prevention system, just network security monitoring, also full packet capture is possible, and then you can do combination of the different one. And firewall mode is the new mode of operation, and you can do some fine stuff. So you start it with dash firewall option, and then you can write something like, okay, I want to drop the flow at the stage where the client has sent the hello in TLS, if ever the GF or hash contain something. So you can just select one implementation of the client, say that you want to drop it if ever you see it pass. Or you can say, oh, I want to drop the flow once I've got the message from the server, if ever TLS 1.0 has been negotiated. So that's just some example. You can use all the flexibility of Suricata with various hooks on which you can act depending on the protocol to take a decision and then enforce the drop of packet, the drop of the flow.
You can enforce policies like that as well.
Yep. So Suricata, it was possible thanks to the OESF team and thanks to the consortium members. And also a big thanks to the community contributors, so mostly the organization here, and the top individual that did contribute to the thing. Hello. And yes, so you got more resources available on the docs on Suricata, which is 500 pages or 600 pages?
More than that. And
Okay.
On the blog, you have a complete list of the whole all features. We couldn't fit everything in here in the talk for sure. So, but one of the points is that there is always a way to contribute and to actually feedback. And one of the most important points is actually the feedback loop, because it will, as I mentioned at the beginning, it gives us an impression how Suricata is used or what problem or challenges you as a user are facing. So that feedback loop is very important. So don't be afraid to read and come back with ideas. Yeah, we actually have once a year a Suricon. Usually we rotate between North America and Europe. This year is Montreal, Canada. That's where the Suricata community meets, and we brainstorm, we exchange ideas.
Just to say a little word about the brainstorm. It's not a brainstorm; it's a roadmap discussion. Where we exchange idea, we get the concept on, the team try to really work on what has been done in the previous year.
Yeah, absolutely. And that's the place really where you want to meet others, the way they use Suricata, the way they employ it, the ideas they have, exchange, get that feedback loop back to the team. There's also 3 different types of training that are there. You meet the community. There is a rule writing training. There's a threat hunting and advanced deployment. Advanced deployment will be led by Eric, by the way. It's actually, we have 10 years of content, a decade. In our archives about those things. So this is basically how to get in touch, how to keep in touch. We're not afraid of criticism as long as we can actually build on top of it and improve. That's more than welcome. Don't be afraid to actually ping us or be part of the community in any way, shape, or form.
And I like to say the first type of contribution is complaining. So if you're using Suricata and it's not doing what you want, please complain, or we're going to explain you how to do it, or we're going to try to find a solution by potentially fixing the code.
Thank you.
Thanks a lot.